So sets, this is a very important topic for us to understand because in every exam, in every paper, you are going to find sets there. In your test 1, you are going to find sets, quiz 1. So in sets, what you want to first understand at this level are intervals. Because in high school, when you are talking about sets, you can remember this type of brackets. So these curly brackets represent elements. So if you have got a set and then you put curly brackets, you are saying that that set has got these elements. It has got the elements 1, 2, and 3. Now, when it comes to a range, you have got closed brackets. If I write 1 comma 3 like this is known as closed brackets. Now, a range is telling you these are not elements. So when you are putting in a set, you can't put this like when you're writing Venn diagram. Let's say this is set A. You can't write it like this. You can't write set A and then you put 1 and 2. This is not correct. Why? Because, sorry, 1 and 3. Because this set is representing a range of values and not elements. So we're talking about all the numbers from 1 up to 3. That's the meaning of a range. So I've said that this is a closed interval. The meaning of closed interval is that when we are the only way we can show this is to represent them on a number line, not in a Venn diagram. You don't represent a range in a Venn diagram because you're talking about a lot of numbers. Just between 1 and 3, you have got a lot of numbers and you can't list them. You have got 1, you have got 2, you have got 3, you have got 1.1, 1.2, 1.2, 1.001, 1.00001. So there is no way you can list numbers between 1 and 3. That's why we can't put them in a number line or I mean in a Venn diagram. Okay. So therefore, if I want to put a closed interval on a number line, you can see at 1, if you see this kind of bracket which looks like this, it means closed. It means that we're including 1. So 1 is actually part of this set. So I'm going to, on 1, I'm going to put a dot. Can you see that I've shaded that dot? At 3, I'm also going to put a dot and shade it and then connect them like this. So this is the set that I've written. There are also open intervals. Let's say, for example, I put negative 3, comma 5. We call this as open interval. The meaning of open interval is that I'm talking about all the values from negative 3 up to 5, but I'm not including negative 3 itself and I'm not including 5. So the way you write it on a number line is you have got negative 3, you have got 5. You are going to write a circle, don't shade it, and write also another circle on 5, also don't shade it, and then connect them. This is an open interval. Are we moving together? Is there anyone that has a question? Hope it is making sense. Okay. So the next kind of bracket that we'll deal with is known as, so let's say for example you've written like this. Look at this. Let's say you have got 1 comma 7. I've started with a bracket that is a bit rectangular like that. This is known as closed, and then I've got a bracket that is circular like that, that is known as open. So this is known as a closed open interval. Closed open interval. So the way you represent this set on a number line is you have got 1 and then you have got 7. Because 1, can you see that on 1 it is closed? So I'm going to shade the circle on 1, but on 7 it is open. I'm going to write as an empty circle like that, and then I'm going to connect these. So this is a closed open. You can also have an open closed. Open closed is something like this. Let's say you have got 0 comma 6. So it means that the way you are going to write this is when you have got 0 here and then 6 here. At 0 you are going to open, at 6 you are going to shade. Hope this makes sense. Are we all together? So in case you want to say something, what you can do is you just open your mic. You can see my screen here. There is where I'm pointing. That's the mic there. Just press there and then you'll be able to ask. So Chad, your hand is up. Do you have a question? So if you press on this hand, it will be up. So it will be telling me you have got a question. So if you don't have a question, press on that hand so that it can drop. Okay? Yes, please. Mm. Yes. Yes. So if it is like this, then it is not included, alright? So you are talking about all the numbers from negative 3 to 5, but you are not including negative 3 and you are not including 5. Yes. Yes, yes, exactly. Okay. So let's make sense of what we have just talked about. But before we look at these questions, because I've put exam questions, let's look at another concept. When you're dealing with sets, you need to know how to simplify sets. It's actually very important to be able to simplify sets. Okay, very important. So what should you know about simplifying sets? And because in high school you did some basics of sets, here we want to know how to shade, how to simplify, and how to work them out. So we know that when we are talking about A intersection B, you can write them on a Venn diagram, right? And it's going to be like this. It's this region here. And then you can also talk about A union B. Union, we know it's combining. Okay? So you are going to just basically get everything in A and everything in B. This is the union. You can also now look at some other simplifications that you'll be dealing with. So there are some laws that you need to know. We call them set laws. So without these laws, you can't be able to work out sets. The first law that you need to know is known as the De Morgan's law. So De Morgan's law tells us that when you have got a set, let's say you have got A intersection B, you can see they're in brackets, and then you have got a complement outside. You can distribute this complement that is outside to those terms that are inside, and it's going to become A, it's going to carry a complement, B is also going to carry a complement. But when you distribute a complement, the sign which was on the middle is going to change. If it was intersection, it becomes union. If it was union, it becomes intersection. So that is what we call the De Morgan's law. We also have what we call the associative law. Let's start with the simple one, the law of commutativity, commutative law. Now commutative is like addition and multiplication. If I say 2 times 3, it is the same as 3 times 2. So the law of commutativity tells that when you have got two sets A and B, it is going to be the same as getting B and then A. So A intersection B is the same as B intersection A. That's the same. A union B is the same as B union A. That is the law of commutativity or the commutative law. The next law is known as the associative law. But before we deal with the associative law, let me talk about the distributive law. So the distributive law, we know from mathematics that if you have got a, open brackets, x plus y, this is going to be equal to 1. Anyone that can tell us what will be the answer if you distribute? Anyone? Be free to speak. Anyone who has gotten the question to answer? So when you are performing a distribution, what you are going to get is you are going to get a, you multiply with this first number, you get a, you multiply with the second number. So that's the same when you have got a intersection, let's say you have got b union c. When you are talking about distribution, you are going to have this a intersection, it's like you are multiplying with b, so it will become a intersection, so this is going to be equal to a intersection multiply with b, so that is going to be a intersection b. Don't forget, you get the sign that is on the middle, which is a union in this case, and then get the same a intersection, now multiply with c, so that becomes a intersection c. So this is the distributive law, right? And then you also have the associative law. The associative law is you comparing just the three terms. You know, when you have got 1 plus 2 plus 3, when I add 2 plus 3, the answer that I find and then I add to 1, it is going to be the same as me first adding 1 plus 2, the answer that I get, and then I add to 3. This is known as the associative law. So if I have got a intersection b intersection c, this is the same as me first getting a intersection b, the answer that I find, and then I say intersection c. So you need to know these. You can see they are very simple laws, very simple, but you need to know them. Is there anyone that has got a question on this? Anyone that has a question? Okay. So having understood those laws, you need to now to also know some rules when you are dealing with sets. Let's say here is our Venn diagram. And here we have got two sets, the set A and the set B. And this is the universal set. When I get a set, the set A, okay, the set A, I do the intersection with the universal set. So where the set A is meeting with the universal set, you can see it's what I've shaded. That's where they are meeting. So every time a small set is intersecting with a big set, the answer is always a small set. That's where they meet. But union, where the set A is meeting the universal set, A union E is the universal set, isn't it? Because you are combining the set A with the universal set. Hope that's okay. Okay. So another thing that you need to know is this. Anytime you get a set, you intersect it with an empty set. Anyone that can help, what do you think is the answer? Remember, intersection is what is common. So let's say this is an empty set. Intersection, let's say the set A has got the elements 1 and 2. What is common between these two sets? Anyone? What elements do you find in this set and also in this set from what you can see? So basically, there's nothing common between an empty set and any set. So the intersection of a set with an empty set is always an empty set. And then the union of a set with an empty set is that same set, because you are combining. Union is combining. These are simple laws, but you need to know. Okay. Also, when you have got a complement of a set, what a complement is, you are talking about all the elements that are outside A. For example, in this Venn diagram here, a complement will be this region. You can see the one that I've shaded. So when you get a complement and then you put another complement there, it will end up being A. So in other words, when you have got two complements, they cancel each other. The last one I want you to know is that when you see A minus B, you are talking about what is in A but not in B. So if I come on this diagram, I can shade. Can you see that what I've shaded here is in A but not in B? So that's known as A minus B. A minus B means A, this part that contains the minus, you are going to put intersection. So the same second term that contains the minus, write it, right? You write B, put a complement. So A minus B means A intersection B complement. You need to know this, you need to know it, you need to know it. Never forget that. It's a very simple principle, but very vital. Let's do exam questions. We see if we have understood what we are talking about. After this, I'm going to give you questions to try by yourself. So make sure that you follow properly, because these are questions you're going to find in your tests, in your exam. Okay. Let U is the universal set. So the universal set is from negative 7 to 10. The set A is from negative 2 to 8. B is from 1 to 8. C is from negative 7 to 6. Please take note of the brackets. If you miss the brackets, you'll not get it correct. The first question we want to find A intersection B minus C. Now, when you are working out sets, the first thing that you want to do is simplify the set. Okay? So A intersection B minus C means A intersection. The B minus C, remember what I said, if you have got a B minus C, it means B intersection C complement. So the way you answer sets is you use a number line. So we're going to come on a number line. And you should always start with what has got a complement if you want to answer sets easily. So we are going to, what has got a complement is C. So we're going to go to the set C. So the set C is from negative 7 to 6. Let's say negative 7 is here, and then we can say 6 is here. So are the brackets given open brackets or closed brackets for the set C? Anyone that can help there? Pardon? What brackets are these given for the set C? They are open. Very good. So we're going to open here, and we're also going to open here. So this is the set C, but remember, for the question I'm interested in C complement. So since C, let's start with 6. Since 6 is not part of the set C, meaning that it's going to be outside the set C. So I'm going to shade that 6, and then I'm going to write a line going this direction. And then since negative 7 is not part of the set C, so it's going to be outside the C. So I'm going to also shade on C, and then I'll write an arrow going in this direction. But remember, they've given us the universal set is from negative 7 to 10. So in other words, when I'm going in this direction, I can't go past 10, because remember, every set is a subset of the universal set. It is inside the universal set. So even the complement of the set C should always be within this universal set. So I can't go beyond 10. So I'll end at 10. But remember, 10, for here we are closing, the bracket is closed. So when I reach at 10, I'm going to shade. Why? because 10 is part of the universal set. But when you look at going to the left side, we can only go up to what? Negative 7. So in other words, I'm just going to put a dot at negative 7. Okay? Because we can't go anywhere further. So what we are saying is that negative 7, you can see, is not part of the set C. So it is going to be outside C. And actually, the universal set is only ending at negative 7. So I'll just put a dot there, just a dot, that's all. So that is the set C complement. So if I want to write the set C complement, how am I going to write it? So C complement, I've got negative 7, but negative 7 is an element. Since it's an element, I'm going to use curly brackets, not interval brackets, curly, like this. And then it's not only negative 7, which is part of the set C complement, but we also have from 6 up to 10. Can you see that at 6 I've shaded, so meaning that that is going to be closed. At at 10 I've also shaded, it's also going to be closed. So this is representing C complement. But since all of them are part of C complement, combine them. So you just put a union in between. That is meaning you have combined this set and this set, and that is what is making up C complement. Is there anyone that is left behind? Anyone that is left behind? Okay. Now, since I've written the set C complement, I can just remove the set C because I'm not interested in the set C. Okay, that is our set C complement. But remember, I want to see where C complement is intersecting with the set B. So I'm now going to put the set B. The set B is from 1 up to 8. So 1 is going to be somewhere here, 8 will be somewhere here. Yes, please. Is that a question? So you can see for the set B, it is from 1 up to 8, and I've shaded both ends because these are both closed interval brackets. And this is the set. Yes, please go on. Okay, so you can see the way the question is. So before you can deal with this, you want first to deal with these two that are in brackets. The answer that you find here, now you are going to intersect it with the set A. Does that make sense? No. So B minus C, we have said it means B intersection C complement. So you want to find B intersection C complement, which is the same as B minus C. Before you can find intersection C complement, first find C complement. When you find C complement, and then you find the intersection of that C complement with the set B. Yes. Okay, good. So this is the set C complement, this is the set B. So we want to see where they're intersecting. Can you see that they're intersecting here? Here. So what I've shaded is B intersection C complement. I can now write it again. It is from 6 up to 8. Can you see that 6 is part of the set C complement because I've shaded? 6 is also on the line for B, so meaning that 6 is also part of the set B. Since 6 is in both sets, it is going to be part of the intersection, so I'm going to shade. And then if you look at 8, 8 is part of the set B because I've shaded, and 8 is part of this set C complement because it's part of the line. So since 8 is in both sets, is going to be part of the intersection, so I'm also going to shade there. So this set that I've shown is B intersection C complement, or B minus C. So since we have found B minus C, we can now intersect it with the set A. So now we are going to go and get the set A. The set A is starting from -2 up to 8. So -2 is here, and then 8 you can see there. At -2 it's going to be open. Same at 8 is also going to be open because of open interval brackets. So this is the set A. And now we are looking for the intersection of the set A with B minus C. Can you see where they are meeting? It's from here up to here, this region. Therefore, we are going to say A intersection B minus C is going to be, they are intersecting from 6 up to 8. 6 is part of the set B intersection C. It is also part of the set A. So it's going to fall in both sets, so we're going to close. But can you see 8 is part of the set B intersection C, but it is not part of the set A because it's open there. So 8 is not part of the intersection, so we're going to put open. So this is the answer for this one. The thing is that if you just miss a bracket, you can write 6 and 8 like that, but if you put like this instead of putting this kind of bracket, it's wrong. Does this make sense? Now for the set C complement, I already answered it. You can see the answer is here. That's the second question. Find C complement. We've already answered it. It's there. So we can go direct to the set, to part 3 of the question. Part 3 of the question, we want to find A union C. So A union C, again, come on your number line. We want to find A union C complement. So first get the set A. It is from -2 up to 8. This is the set. That's set A. And then the set C is from -7. -7 will be more this side. Up to 6. 6 will be somewhere here. And it's also open at both ends. This is the set C. Now union means combining. I know we know that, isn't it? So union means combining. So combine these two sets. So you combining means you are going to start from here. You are joining these sets. You are going to continue. Can you see where we are ending? So we are starting all the way from -7 all the way up to 8. Because -7 is not part of the set C, it's still not going to be part of the union. And then because 8 is not part of the set A, it's still not going to be part of the union. So this is a set A union C. But we don't want A union C, we want A union C complement. So complement, we want what is outside. So since 8 is not part of the set A union C, it is going to be outside A union C. We'll be going in this direction. But remember, the highest that we can go is only up to 10 because that's where the universal set is ending. So we are going to go all the way up to 10. And 10 is part of the universal set, so shade there. And then on this side, since -7 is not part of the set A union C, it means that it's going to be outside A union C. But I'm not going to be going in this direction. Why? Because the universal set is ending at -7 itself. So I'll just put a dot at -7. Therefore, A union C complement is -7. -7 is an element, so I'm going to put it in curly brackets, not interval brackets, and then union we have got from 8 up to 10. You can see both 8 and 10 are shaded, so we are going to put them like this. So this is how you answer this question. Anyone that has got a question? Is there anyone with a question? Okay, we can also try this. Let's start with the first one here. They are saying for any two sets A and B, simplify. So for this one, we want to simplify A complement intersection A complement intersection B, it has got a complement outside, and then we have got another complement outside. So how do we do this one? The first thing is get the complement that is outside the big bracket, you distribute inside. So here you are going to take this one as one thing and then this one as one thing. Remember what I mentioned about the De Morgan's law? So we are going to distribute this A complement is going to get another complement, which one? Coming from the outside. And then I'm also going to write this part A intersection B, A complement intersection, it has got a complement. It will also get a complement that is coming from the outside. But remember, the sign here was intersection. So what will the sign change into? What is it going to become? Anyone that will help there? What will the sign become? It will become union good. Remember what I said, if you have got two complements, what does it mean? What happens? So when you have got two complements, they cancel themselves out. Okay? So A complement is just A. And then union A complement intersection B. Also these two complements will cancel themselves out. Now at this point you can use the distributive law if you want. You are going to say this will be A intersection, A union, it will be A union A complement. So it becomes A union A complement. Remember to get the sign that is on the middle here. So now say intersection, and then the same A union, it will go with B. So that becomes A union B. Now, when you have got, this is a set A. When you get a set, you combine it with what is outside it, or A complement union A. One, what is inside? A complement is what is outside. So if you combine what is inside and what is outside the set, you are going to set. So this is one thing you need to know. A complement union A is the universal set. But when you look at A and A complement, there's nothing common between them. You can't find an element inside the set and outside the set. So A complement intersection A is an empty set. But A complement union A is just going to be the universal set. The universal set. So that would be universal set intersection A union B. And remember what I told you? Every time you get of any set with a universal set, the answer is that same set. So the answer is A union B. But if it was union here, the union of any set with the universal set is always the universal set. If it's the intersection, it is always that set. So this is when you are simplifying, you don't want to see the same letter twice. So after I simplify, I don't want to see A and A again. I should only see A once, and I should only see B once. That's what we call simplifying. Okay, hope that's okay. And then we can work out part B, which is saying given that A is 0, 5, and you can see those are curly brackets. These are elements, it's not a range. B is from -2 to 2, and then C is from -3 to 2. Want to find A intersection B. So to start with A intersection B, let's start with the set B. The set B is from negative up to +2, and it's closed at -2. It is also closed at 2. So set B. Now the set A is 0 and 5. I've said 0 and 5 to 5. 0 and 5. Why? These are elements. It's not a range. Look at the type of brackets. Those are elements. So at just put a dot. At 5, just put a dot. This is the set A. Please don't connect them. It's not a range. They are elements. So when you look at the intersection, where do you think these sets are meeting? So what is, you can see 0 is part of the set A and part of the set B. 5 is not part of both sets. So the only point where the two sets are intersecting is on 0. Okay. So please don't open your mic. Don't open your mic. It's disturbing. Don't switch on your camera and make sure that your microphone is closed. Should I remove those people whose microphones are on? So if your microphone is on, kindly switch it off so that it doesn't disturb the class. Okay, good. So I was saying that if you look at these two sets, the set A only has got elements 0 and 5. 0 is also in the set B. 5 is not part of the set B. Therefore, the only thing that is in the set A and in the set B is 0. So therefore, A intersection B is only 0. So write 0, and one element you use curly brackets. You don't use a range. When you're using, you always start with a small number and then write a big number. So it's not correct to write 5 and then you write 1. You always start with a small number. But for this one, it's just an element, so just write 0 and put it in curly brackets, not interval brackets. And then we can go to the second part of the question. We want to find A complement intersection B. A complement intersection. Let's first write the set. Remember I told you to always start with what has got a complement. So the set A is only 0 and 5. So just put a dot at 0 and put a dot at 5. This is a set A. But we want A complement. A complement is going to be everything except 0 and 5. So I'm going to put an open circle. At 5, I'm going to put an open circle, and then now connect them like this. You connect here, also connect, so you'll be going all the way to the numbers this side, all the numbers this side. Everything else is outside the set except 0 and 5. That's why at 0 and at 5, I've put open intervals. Okay. And then we want where this set A complement is meeting with the set B. The set B is from -2 up to +2. So -2 is there, and then +2 is there. That's the set B. So we want where the set A complement is intersecting with the set B. So where is that? It's from all these up to 2. But remember, 0 is not part of the intersection. Why? Because 0 is not in A complement. Therefore, we are going to say A complement intersection B is first starting from -2 up to 0. So -2 is part of B and is part of A complement. So I'm going to put open. I'm going to put close. 0 is not part of A complement. So put open. So we are saying from -2 to 0, and then we'll continue. So union, and then from 0 up to +2. You can see 2 is in both, so close at 2. So this is a set A complement intersection B. That's how you answer it. Now B union C is going to be very easy and direct. The set B is from -2 up to +2. It's closed at both ends. And then the set C is from 3 up to 2. So it's going to be open at negative 3, is also open at 2. Remember, union is you combining the sets, so simply negative 3 up to 2. Therefore, B union C is going to be from negative 3 up to 2. Can you see that negative 3 is not part of the set C? So it's not part of the union. And then when you go at 2, so the set C is from negative 3 up to 2, and it is open at both ends because of the open interval bracket. So it's from negative up to positive 2, right? And then we are talking about the union. Union means combining, so we'll get all these elements from here going like that. So we are combining the two sets A and B, so up to that point. So that will be the union. So B union C is going to be from negative 3 up to 2. But negative 3, since it's open, it means that it can't be part of the union because it's not part of any set. So I'm going to open also at negative 3. But when you look at 2, 2 is not part of C, but it is part of B. Now union is different from intersection. If it was intersection, 2 is not going to be part of the intersection. But union means combining. If I've got a 2 quater, you don't have a 2 quater. If we combine all together, we are going to say we have got a 2 quater. But if we say what is common between us, there is nothing common because I've got a 2 quater, you don't have. So that's the meaning of intersection and union. So for union, 2 is going to be union set because it is in one set. If it was intersection, an element can only be part of the intersection if it is in both sets and not only in one. Does this make sense? Let's work out. Okay, this one I'm going to leave it for you to answer as a practice question. We can do this one as a last one. Simplify the following as much as possible where A and B are any sets. We have got A union B intersection A union B complement. So remember what we said from the distributive law. If I've got this, got xy plus xz, you can see x is common, right? We can factorize it so it becomes x y plus z. That's the same we can do here. Okay, a union is common, a union is common, so I'm going to like factorize out a union. So what will remain here is a b, and then we'll get this sign which is the intersection. What has remained here is a b complement. And we had said when you have got a set intersection its complement, the answer is empty set because there's nothing that is inside the set at the same time it is outside that same set. And we also said that A union empty set is the same. But if it was A intersection empty set is empty set because there's nothing that is in an empty set but is found in a set. But if you combine a set with an empty set, you get that same set. So the answer is just A. We have simplified. And then for B, we have got A complement union A intersection B. A complement there. There's a complement outside, and then there's another complement outside. So what you do is start with the complement outside everything, that one. So it will become A will carry two complements, and then part here that is A intersection B, it has a complement, it will carry another complement, but because this is union it will become intersection. So the two complements are going to cancel. We're just going to have A and then intersection. These two are also going to cancel, so we have A intersection B. Now just at looking at this, A intersection B is actually part of the set A, so meaning that if you intersect a big set with a small set,